This is the future of high-speed transportation. It's 3.5 times faster than Japan's Shinkansen bullet trains, and even faster than a Boeing 747. It's a Hyperloop, magnetic pods levitating inside a tube at more than 1,000 kilometers per hour. In theory, you could go from LA to San Francisco in just 45 minutes, with tickets less than $100 one way. This technology could make working and living in two different cities a norm, while also creating a world with less congestion and pollution.
Yes!
And with a successful human test ride in November 2020, we could be less than 10 years away from it becoming reality. The concept of the Hyperloop became widely popular in 2013 thanks to Elon Musk's 58-page Hyperloop Alpha paper that outlined the design, cost, and safety of the concept. But the technology to bring it all together commercially was only recently fine-tuned, namely magnetic levitation, or maglev. Maglev is basically what allows a Hyperloop to go incredibly fast, thanks to the lack of friction between the passenger-carrying pods and the tube-shaped track. The general concept is simple. Magnets lining the bottom of the pod repel the tube material, levitating the pod as it runs.
As an engineer, I always get very excited about talking about magnetic levitation, electromagnetic repulsion.
That's Josh, a mechanical engineer who previously worked at SpaceX. He's now the co-founder and CTO of Virgin Hyperloop. And this is Chuck. He's the lead engineer at a different Hyperloop company, Hyperloop Transportation Technologies. They're both currently developing the best combination of magnets to create the smoothest ride possible, using passive or active maglev. Passive maglev uses permanent magnets in a specific configuration to create a constant magnetic current that levitates the pod, similar to the magnets you might have played with as a kid. Active maglev uses a combination of permanent magnets and electromagnets, the latter which can manipulate the electric current and the strength of that current.
Basically, if I get too close, I drive it one way. If I get too far, I add some strength. And so you can kind of think of it as balancing out. And so if there's bumps in the track, if there's all this, I have a system which we basically use as an active control system to make that ride smooth.
And while you might think this sounds similar to existing maglev trains, the Hyperloop concept removes a key element that holds a lot of trains and planes back: air resistance.
If you ever stick your hand out a window when you're driving in a car, imagine if there's really no air there, you really wouldn't feel that force pushing back your hand. And the same thing can be said for a Hyperloop.
This is where vacuum pumps come in handy. Both companies are installing pumps along the tube. For Hyperloop TT,
the vacuum pumps in our case are developed by Leibold, which invented the vacuum pumps about 150 years ago, so they have a lot of experience.
These pumps, located every 10 kilometers, theoretically would suck out 99.9% of the air between the capsule and the tube. Removing air drag could be the difference of some 800 kilometers per hour.
Theoretically, you could go even faster than the speed of sound, but that's toying with some fun things that we'll do later on.
It's going to take a little bit more time before we go supersonic, though. First, the companies have to prove the tech is safe, which is why this scene is so important.
Yes! That was so good! That was awesome.
In November 2020, Josh and Sarah from Virgin Hyperloop became the first people to ever ride a Hyperloop. The two-seat prototype Hyperloop traveled 500 meters, reaching 172 kilometers per hour within 6.25 seconds.
You felt a bit of force back in your seat. You really couldn't even notice the levitation. Like, you didn't notice it pick up. But what you did notice is there wasn't that kind of jerkiness. The camera didn't do it quite justice because the camera was bouncing around a bit more than we were. And it was, a little bit more of like a cushion or like a pillowy type of feeling. You could process everything that was going on around you. You're basically coasting and you're floating on an idea that was nothing more than something on a piece of paper not all that long ago.
While the ride proved its safety, the company wants to work more on the experience. And the actual Hyperloop will be much bigger too, holding 28 or more passengers, with the ability to move 30,000 passengers an hour. But to get to this point, there will be more testing involved for both companies.
Lots of things have to happen between now and then. The Hyperloop construction, the route is one thing. The integration with the stations is another, and that takes a partnership with the communities.
And Hyperloop TT is currently in the works to build and test a full-size project in Abu Dhabi, Its first potential U.S. project will run from Chicago to Cleveland. Virgin Hyperloop will be building its new certification testing facility in West Virginia in 2022, including a 9,600-meter track to be used for testing and establishing regulatory and safety guidelines.
Around 2025, we're intending to certify a fleet of vehicles, of the 28 passenger vehicles.
Virgin Hyperloop has plans in Dubai, India, and more, with stateside plans for the Midwest, North Carolina, and Texas. But both of these US projects won't be complete until around 2030, which might sound like a long time, but airplanes took about 16 years to really get up and running, and the first high-speed rail in Japan took at least a decade of development. So some 15 years for a Hyperloop doesn't seem that far off. After all,
how can we be a 22nd century country when we're built upon the technology of the 19th century, upon the 20th century? A single lane of Hyperloop can do in excess of 30,000 passengers an hour. What are you going to invest in? What's the thing that you should invest in that allows you to get the future demand, the future needs that you have? A shift is possible if we choose to embrace it.